This is the K2 Pro, the newest of the K series from Creality. You're probably familiar with the K2 Plus, a 350 by 350 by 350 beast with a heated chamber and a max hot end temperature of 350 degrees. The K2 Pro feels very much like that printer besides the size. This is 300 by 300, but there are differences. Let's get into it. Okay, basic specs first. This is a 300 by 300 printer, as mentioned before. It has a max speed of 600 millimeters per second, a max acceleration of 20K. The hot end goes up to 300 degrees. The heated bed goes up to 110 degrees. It has a hot end heater of 70 watts, and it also has a nozzle with a steel tip for abrasives. So compared to the K2 Plus, this is actually more of a light version because the K2 Plus had a max acceleration of 30K. This is 20K. The hot end went up to 350 degrees on the Plus. This goes up to 300. The heated bed went up to 120 on the Plus. This is 110. And the hot end heater actually went up to 100 watts, and this is only 70 watts. On its own, the K2 Plus was 1,100 euro. This will be 900 euro on its own. So why do they call it the Pro when it's quite obviously a light version of the Plus? Well, they're going to introduce the standard K2 as well, which will be smaller, and that will be for around 500 euros. So this is a Pro version of the standard rather than the Plus, just in case that wasn't clear. This printer uses step servo motors, has 2 lead screws on each side for Z motion and dual steel rods on each side for stability. And for XY motion, there are steel rods on the left and right, but a linear rail on the gantry, much like the Plus. The motors are closed loop, meaning you should not get any lost steps, meaning there should not be any layer shifts. And I'm actually quite impressed with the motors, the noise of the motors. They are surprisingly quiet. Unfortunately, the fans kind of balance that out. So let's do a noise test. Here's what we got. As for hot end performance, besides the size of this thing, I think that's what sets this apart from the Plus, because the Plus went up to 350 degrees. It could print things like PPS. It was designed for engineering materials. And I think that embodies Creality's agenda for their flagship project, because they wanted to appeal to engineers and prototypers, much like Bamboo did when the X1C was released. They flocked to it because it was reliable and could print engineering materials fast and reliably, and in some cases much better than the printers that they had that cost tens of thousands of euro. Printer manufacturers have recently gone down this route. There are a lot more printers with high-powered hot ends and heated build chambers. The Plus was one of these, but the Pro is definitely not. This is for hobbyists, and yes, it can print things like nylon and ABS really well, but it's not designed to print something like PPS, because most people don't print PPS, most people don't need PPS, and most people will be satisfied with the light version. But I do really like printing ABS, so let's take a look at that heater and see if it can actually hit 60 degrees. We started the test at room temperature using both the printer's thermistor and an independent thermocouple with the probe just next to the poop chute. The printer takes a while to perform calibration, about 15 minutes actually, and during this time it doesn't actively heat up the chamber constantly. So we're going to start our test from when the printer actually starts printing. It is only at this point that the chamber heater starts heating with a target of 60 degrees. At the 12-minute mark, the thermocouple achieves 60 degrees, but the printer registers only 51 degrees. The thermocouple is relatively close to the heater, hence the discrepancy. The print continues until around 36 minutes when the heater stops actively heating at 58 degrees. The nozzle is steel tipped as mentioned before, and it is the exact same one that you would use on the Plus. However, it is not the same as the very, very, very similar unicorn nozzle that is used on the K1C. The Plus has a 100 watt heater and the Pro here has a 70 watt heater. However, they both seem to have the same advertised maximum flow rate, which is 40 millimeters cube per second with ABS at 280 degrees. Despite the difference in power, they both seem to have the same flow rate. I actually asked Creality about this and they confirmed one is just a slower heating hot end. But Let's try it out. We're going to try our own ABS and our own EcoPLA and see what the volumetric flow rate is for those filaments on this printer. With Creality Print's max flow calibration, we can just see where the print failed, measure the distance to there, and see what the flow was at that height in the preview. For our EcoPLA at 230 degrees, we got to a height of about 55mm before things went south. According to Creality Print, at that height the flow was 32.68mm³ per second, and that was for our own PLA, which is pretty standard. I gotta say though that would be the absolute max. Things did not go well after that. For our own ABS, well, that was more interesting because I had to extend the flow range, and we actually got a flow of around 53.5mm³ per second at 270 degrees. Interesting. The printer also has an activated carbon filter to reduce any particulates and fumes from reaching the environment. It also has an RFID feature, like a lot of printers these days, to automatically detect which Creality filament you are going to put on the spool holder or in the CFS. The screen is very much like the X1C, and I do like it, although it does take a couple of seconds to go from standby to active. There is a ton of info and options available. I think they did a great job with this. Just so you know, when we got this, the AI features were actually turned off. By default, you have to turn them on in the settings on the screen. Yeah, this thing has an automatic flow and pressure advanced calibration, which is pretty neat. The only thing with this is it doesn't seem to save to your Creality Print profile or what you selected in the printer, and I don't see if it is actually used in Creality Print, but I can see that it is being measured in the fluid interface console, so I am assuming that it is being used during the print. Creality printers have recently had bad juju for their not-so-flat beds. After doing a bed leveling, you can see that the mesh is not perfect with a range of 0.295, but it seems to be small enough for the printer to compensate, as I got a decent first layer test. As mentioned, the newer versions of Creality Print have some similarities to Orca Slicer actually, which is a plus. Creality Print has all of the usual accoutrements as Orca, such as choosing the build plate type, adding multiple build plates, basic CAD features like holes, hollowing, cutting, embossing, and measuring, and the color features like flushing volumes too. The Creality interface is fine, but it doesn't give you much control. If you want to see all of the fun stuff, you can use the fluid interface to interact with Creality's version of Clipper. And of course you have a big nice view of your printer's build plate as your model is printing, so you can do time lapses or keep an eye on the print from the comfort of your office as you gorge yourself on K-pop. There is also the nozzle cam at the back of the print head, which is used for pressure advance and flow calibration, and to check if the poop chute gets blocked. As far as I know, there is no way to do a standard time lapse with a nozzle cam, but there was a Reddit post where someone got access to view the nozzle cam on the Plus version, and I've linked that below if you're interested. The CFS just works. I've had zero issues with this, and I prefer it a lot more than other AMS units like the Anycubic Ace Pro. It is well linked to the slicer because we actually do have control over the individual flushing volumes, unlike the Ace Pro. There is also a screen for quick checking with humidity and temperature readings. The downside of this though is it doesn't have a dryer, and while it does load the filament really quickly, it does it one at a time. There is of course the filament sensor in the CFS that auto-loads the filament when inserted, but the printhead itself also has a filament sensor, so no wasted filament. The CFS also checks spools with an RFID to see how much filament there is left, which is pretty neat. Alright, now there is nothing left to do but take a look at what we printed. Multicolor came out well. We see no color bleeding or other flushing related problems here. However, there was a small artifact during the color change and also the top layer of the head, which translates through to the ears. We didn't see many similar problems in later prints though. Everything else came out pretty nicely. This was our first ABS print, which was mostly just a test to see how well the chamber heater worked and also to test out support Z distance, but I decided to push it a bit more with ABS and I printed this huge Velociraptor. This came close to the maximum size possible in the printer and I'm pretty happy with how it came out given the size. This was Spectrum's silver PETG carbon fiber and the surface texture came out beautifully. This is a very nice filament. I think I'm happiest with this one though. This is our matte PETG. You wouldn't think it is a PETG, it looks like a matte PLA. The only issue here was the overhangs, and I had a similar problem with TPU, which is normal for TPU, but I think the generic profiles on Creality Print need to be adjusted for overhang slowdowns, at least for some of our filament. Our TPU came out okay, but well, more on that later. Okay, so a few weeks ago we teased the K2 Pro and asked you guys if you have any questions about the printer, and we got some, which we have not so far addressed, so here we go. First up is Brad Ruffalo, who asked, how does it stack up against the P1S? P1S is a great printer. We have one in the shop. It's well priced as well. It's only €500, which is pretty decent for the quality that you can get out of it. But it's missing a lot that the Pro has. So first of all, it's smaller. It doesn't have a great screen. Anyone who has a P1S and you've used the screen, you know what I'm talking about. There is no automatic flow calibration on the P1S, unlike the X1. There's no chamber heater, but of course, if you're just comparing print quality, the K2 Pro is probably like slightly better, let's say. In most cases, I would probably recommend the P1S to a beginner over the K2 Pro, because they just might not need the build volume, the heated chamber, and then there's already a ton of information about the P1S online, so it's a lot easier to use. And of course, there's just the price. So 500 versus what, 900. But if it was me, I would probably go for the K2 Pro. It really depends on what you're using the printer for. If you're just using PLA and stuff, then you'd be fine with the P1S. It's standard sized. It's good enough. But the K2 Pro, obviously, it's bigger. It has the heated build chamber. If you're printing a lot of ABS or more engineering materials, then yeah, it's just better to go for the K2 Pro. Remember, this thing also is clipper based, so you can change things compared to the P1S, which is just closed off. Next question is from Delonia. I'm interested to know its performance in TPU printing. So you guys saw the print results. That was 95A, which is pretty standard TPU. They came out okay. 95A works out fine, but last week we did a video on flexible filaments, and we're testing lots of flexible filaments down to a shore hardness of 51A. We also tried a 60A, and we have tested on the K2 Pro some, I think it was 82A. I couldn't use the K2 Pro for those filaments. 95A, totally fine. But the softer ones, no, the extruder just scrunches it up. It doesn't work. The extruder, which is the same as the K2 Plus, is just not well suited for softer than 95A filament, because the spring is just too tense. There are workarounds like adding a spacer like this one. I've linked this below, but bottom line is if you want to print softer than 95A, you got to work around the extruder. Next is I Play Video Games, asking, on the Creality K2 Plus lid, the safety lamination is placed on the outside, and I'm noticing that the Bowden tube leaves unwanted marks on that surface. Have they changed the lamination process on the newer K2 Pro, such as putting the film on the inside, to prevent this from happening? Because on my K2 Plus, the Bowden tube has scratched the plastic coating. No, this isn't a user removable plastic. It's for the laminations to stop the glass flying everywhere if it shatters. So firstly, the lamination is on the inside. I guess that's what you meant, because I have noticed this too. There are scuff marks on the inside of the lid. I spoke to Creality about this, and the lid used is the same as the K2 Plus. It's the same manufacturing process. So there is a coating on the inside. But the PTFE isn't scratching the plastic coating on the lid. Actually, it's kind of the opposite. The lid is scratching the PTFE, because the PTFE is self-lubricating. A little bit will come off if it hits something, if it touches something. I wasn't entirely sure about this, by the way, but PTFE reflects light that's close to UV pretty well, and you can see that it is the PTFE residue on the glass. Porkbelly asks, is the K2 Pro compatible with the K1 Max build plate? Yes, it is compatible. I have used it and it is compatible, which is awesome. I hope this video has helped you guys if you are considering a new printer. Of course, if you have any questions, you can let us know down below in the comments section. You can also join our Discord server, where there is talk about printing on a daily basis. We'll be back with another video in next week, so until then, later.